Thank you very much. So I'm really glad to kickstart this last day of the conference, and let me share my screen. Where it is? Desktop.
And I forgot to mention that something that is not in your biography, but Larysa started this awesome MLOps repository. So you should, if you haven't seen it, you should definitely go and check. And like you can find here on Twitter, and the link is there. So just check. This is a very it's a great resource if you are starting with MLOps. There are many articles, many links. So yeah, definitely go and check.
Thank you very much. So you can see my screen, right?
Yes.
Great. Good. Okay. So thank you very much for the introduction and for the introduction of awesome MLOps. All right. I work as a software consultant at InnoQ, and like a software consultancy, my colleagues are often asking me what is the actual difference between developing software, traditional software, and software which contains machine learning. And this is in this talk I gave to my colleagues to explain actually all that stuff. And I see machine learning engineering as a set of principle techniques from machine learning and software engineering in order to design, build, and deliver machine learning based software. And usually I start my presentation with this slide where I explain the difference between programming and machine learning in order to get this distinction clear. So in programming, we have data, we have our program, we put it in the machine, and then we get the output. In machine learning, we will need to take an additional first step, which we call training, in order to actually produce this program. And this program is called machine learning model, where we get our data, get the labels or outputs, put it in the machine, and from these data and outputs we will train the model, which then is used on the new data to produce the output. And there are actually three fundamental components of machine learning engineering, which are data, model, and code. And whenever we have a changes in our data, we will have a change in our code, which probably will the changes will propagate to the code. And and all these three components need to be so we need to make clear that the machine learning systems will be more complex just because of changes on these three levels. Well, let's go to the 10 machine learning engineering principles, and I organize them as a hierarchy of needs. I think this metaphor is very useful for us. I don't have answer for anything, but I have some experience which I will share with you, and probably this experience will be useful to you too. Let's start with the first and most important question, which we have to ask not only before machine learning project, but also before any software project. Like, what is the business problem what we are trying to solve here? Usually I have the following pattern where people come to me and say, we have so many data, we collected so many data, historical data, we definitely need to apply machine learning on these data. And I try to calm down a little bit this discussion, and first question I say, okay, what is the problem what we are trying to solve? What are the pain points? So do your users have a pain points with your software? So, and if and then we will go and ask ourselves, is machine learning then the right problem, right technology to solve your problem, to solve your pain points? And usually the rule of thumb is if you have an algorithmic solution for your problem, don't go out for machine learning. Machine learning problems usually we distinguish four kind of machine learning problems or problems where machine learning is a suitable solution. Such problems usually are big, right? So we have more movies outside there than we can watch in our entire life. Machine learning problems are open-ended problems, so we have Twitter streams, video streams, and so on. So machine learning problems are usually time-changing, so we need the systems which can learn with the changes. And usually machine learning problems are intrinsically hard problems. The examples are natural language processing, image recognition, video processing, audio understanding, and so on and so on. So these kind of problems are suitable for machine learning. And you know, the first stage of any machine learning project, business and data understanding, is really crucial. And when I started first in this area, I was looking for practical methods, how to actually identify use cases for machine learning. And I found nearly nothing. And this was the reason why I and my colleagues developed a method to identify business use cases for machine learning. So what we did, we combined two parts. Our first part is we took domain-driven design knowledge crunching methods. We took event storming method and combined it with machine learning design canvas, which is developed by Louise Torard, and used event storming as it said, knowledge crunching to understand the system, to dissect the system on an atomic level, to understand all processes and workflows in the system, and identify the pain points in our system or problems in our system. And then we will ask or we decide and prioritize these problems, whether they suitable for machine learning. So, and after that, we go and try to prototype the system, the machine learning solution or structure or project with machine learning design canvas. And I really recommend to go for and have a look at the design canvas to structure your machine learning project on a high level. Right, so the machine learning design, this canvas consists of 10 elements, and the central the tower is about value proposition and life monitoring. So we identify or we state what is the use case, what is the problem, how can user benefit from the machine learning solution. And the life monitoring is actually, how do we know that we are doing well? So we try to identify all the business metrics and put it here. So, and then we have left and right part of this canvas. And the left part is about prediction. All the aspects of the prediction, what is the what is the prediction task or machine learning task? What decisions are made? And especially interesting is the offline evaluation or impact simulation. How do we know? How can we simulate that our machine learning is getting the value to our customers? And the right part is about data. Is about data or training step of machine learning. So we will come back to this kind of several times in my presentation. So let's move to the next point, and the next point is about staffing. So if you have machine learning project, you will have you will need skilled people, and usually we have the data engineer who work with data sources, curates the data sets, and prepares data for data scientists who looked at the data, trains model, and give these models to MLOps engineer who brings this model into production. And if you look at this, this picture is quite idealistic. So you won't find a lot of MLOps engineers right now. And what we did the following. In my project, we found a DevOps engineer who was curious enough to learn about machine learning. And we found a machine learning engineer who was curious enough to learn about the DevOps and all the procedures, how to bring machine learning into production, how to deploy machine learning. So, and we paired in GIST, and the whole MLOps engineering was done by two people. And they learned from each other, and and they were ready to do this as a pair programming. So this works very well. And this is actually my recommendation how to solve this shortage of skills for machine learning operations. Right, the next point, machine learning project management. The most common or most popular complaint about machine learning projects is because of their ad hocness, right? Because we cannot really avoid it, because machine learning is, because of its nature, it's experimental. So we have to try out many things also because the data may not give you an answer, and more data may also not give you an answer, and so on. At the same time, machine learning projects are not really well organized. They are not documented. People are working with Jupyter notebooks, so the execution routine or execution cells are messed up, so they are not repeatable, all the experiments. These are most complaints which I get about machine learning projects, but there are already initiatives about how to tackle this problem, and two of them I really recommend to look at. The first one is a cross-industry standard process for machine learning applications with the emphasis on testing. And they define the 6 project phases and describe the details of what's going on from business and data understanding and through the deployment and monitoring. So I really recommend to get the paper, and it's nice read, and you will get the idea about the project machine learning lifecycle. Another one is a team data science process, which was suggested by Microsoft, and they not only give you the description of a lifecycle, they also give you some templates which you can use. and like a project template, and this is a structure for your machine learning or data science project, which will give you clear structure to separate your data, your code, and your models and configurations. So have a look at this and try it out. Really nice. I have a good experience with this. Okay, this is a data talk club conference, so we will talk about data right now. And data is a fundamental part of machine learning because without data, there won't be any machine learning. So in order to get to machine learning, we will need to make sure we have a solid data infrastructure to collect, store, transform, clean or data, to do a feature engineering, and then we will set up our machine learning initiatives exactly on this infrastructure. Back to our machine learning canvas. I told already that the right part is about training, and training is about data. This machine learning canvas will force you to think about what data sources, what raw data we will have or need to have for training. How can we get new data in order to retrain our data? And here, before we start a project, we will have to think about feature engineers. What features do we need? Do we need additional sources for that feature? So this is, so you see that machine learning canvas is a very useful framework which forces us to think about many stuff which are not obvious before we start a project. Well, the next point is about machine learning algorithms, machine learning task, because it's not trivial to translate business problems into machine learning problems, especially if you don't have experience with it. So we have, and this is not trivial because one machine learning algorithm can solve different problems, and one business problem can be solved in different ways in machine learning. And we classify all machine learning according to 3 dimensions, like the kind of problems, the explainability of machine learning algorithm, and the performance. And depending on your experience, on your level, or requirements, you might want to stick with simple models because of their explainability, because they are easy to understand, and especially if you have regulatory requirements where explainability is a must. So you will have to go with the simple algorithm like logistic regression, linear regression, decision trees. But with experience, it's obvious that you will get into the more or high performance algorithm like deep learning or ensemble methods, but it's not advisable to start with them. Good. The usual way and very pragmatic way to start with no ML solution. And before we start, the first translation from business problem into machine learning algorithm, we will need to define the solution, heuristic as a solution, and this will be our baseline. This will be our baseline because this is our first machine learning model deployment criterion. This is important for many reasons. We might need this heuristic in order to persuade our decision makers that yes, machine learning will give you the benefit and will give you value for your software, and like I said, this will be deployment criteria, and there's a nice pattern called heuristic benchmark, which we can apply in our initial as an initial step. For example, if we translated our business problem as a recommendation problem, so we can use a most popular item in our training data as a benchmark, or for example, for anomaly detection, we can use 95th percentile value to identify what are outliers, and so on and so on. And I think you introduced Sarah today. So this pattern is from her book, Machine Learning Design Patterns. So I'm looking forward to her talk as well. Well, the next point is about the flywheel of machine learning systems. And when I explain machine learning, when I explain the life cycle of machine learning models, I always tell that a machine learning model is like a Tesla car. With every update, it gets better. Like we have better models, we will deliver better or more value to users. We will get more users, which will get our more data, and more data will update and make our models better. So, and this flywheel, we have to understand this life cycle of machine learning, and this is another aspect to understand here is that the post-deployment of machine learning will be as important as pre-deployment, right? So you will need to set up machine learning monitoring and alerting, and so you will need to monitor not all the usual system metrics, but also the machine learning specific metrics like performance of machine learning model, if you have labels, if you're lucky, and or you can monitor the inference time of machine learning, the input distribution, or what values are produced by machine learning, the distribution of the outputs of machine learning. Because we have this phenomena of machine learning model decay, that means when machine learning is live, the performance usually drops, because machine learning model is trained on historical data and live data. So probably it hasn't seen the data before. So this is why we need to keep the retraining all the time. And if we are pragmatic, we built already our CI/CD pipeline for continuous integration, continuous delivery, when we define the benchmark. So then we can reuse this pipeline to improve our models. And the improvement can be done in different ways. It can, for example, the model can be retrained, or we decide for another algorithm and exchange the model, or you can use the this heuristic as a fallback plan if something went really wrong. Right. The another point of the automation of machine learning CI/CD is, or in general, the prerequisite for CI/CD pipeline is testing. So in particular, green tests. Machine learning testing is more evolved than traditional testing. So we will need to include, so we will need to provide tests for functional and non-functional requirements like robustness, interpretability, fairness, and so on. So this is also a huge topic, and a lot of going on here in research and in the industry. Right. The next point of the hierarchy of needs for machine learning engineering is versioning. This is also an important aspect and prerequisite for automation to streamline or shorten the cycle time of machine learning development. And versioning is used to trigger the CI/CD pipeline in our application, or it is especially if you are in a regulatory environment. So these are checkpoints for recovery, for traceability, and decision justification. Well, what we need to understand, and this is why I put the my second slide with 3 components of machine learning, is that that machine learning systems, 3 things need to be in sync every time: machine learning models, data, and code. And that means with new data will be produce new machine learning models, and probably some code changes will be required as well. So, and all the changes need to be versioned. Practically, we have a really good experience with DVC. DVC is a data version control. Is used for data versioning, for machine learning versioning. It can do much more stuff, and the or data ops engineers could learn this tool very quickly. This is probably why we had a good experience, well, and luckily we have Elle later these days, so she will do much better job in explaining data version control. So make sure you don't miss her talk. So let's go on to the 8th point of machine learning engineering principles, which is about design of machine learning software. So in order to, what we also need to understand here, that the life cycle of machine learning models and the life cycle of the base software might be different. So, and we probably don't want to rebuild the whole system just because machine learning, just because we renewed the machine learning model. So that means the machine learning models should be replaceable, and the software design for such quick changes or seamless changes is a loose coupling principle of software design. And depending on your architecture style or the architecture of your core system, be it monolithic or distributed, you might want to stick to different architecture styles. For example, if you have a monolith software system, you can use the microkernel architecture, which is flexible architecture style and contains two components: the core software systems, and the business logic is distributed across the plug-in components. And such plug-in component can be or machine learning model, and the communication is point-to-point, and the core system usually have a registry where you can register your various components, and you can also use so you can replace the plug-in or your machine learning model on runtime without the need to rebuild the whole system. Well, in the distributed environment, and this is the quite popular pattern, serving pattern for machine learning model, is a model as a service where we wrap the machine learning model as a web service and expose it through the REST API to the target application. And from the infrastructure point, we encapsulate all the technical stack of our machine learning model as a Docker container, and the Dockerization is de facto as a standard right now to expose or to serve or machine learning models. Well, so all that aspects that I mentioned before are somehow belong to the MLOps, which is the extension of DevOps to design, to train, to build machine learning based applications, and where we put machine learning model and data as a first-class citizens. And there's a lot of noise right now about MLOps, and the amount of MLOps activities and amount of MLOps components will depend on the AI readiness, the maturity level of your company. So, and if you're just at the beginning, you might have just simple use cases for machine learning, and you might have manual deployment, and what we are going to do here in the tactical phase, we learn how to deal with machine learning. We learn this technology. We learn to fail on this, and if we have some use cases, we will deploy on an ad hoc basis. So we are just learning. So the next step will be a strategic phase where we utilize pipeline patterns. And use cases getting more serious. They are aligned on the business objectives, and we have specific workflows, and or models are exposed through the APIs, usually REST APIs, and in the last stage of the AI readiness transformational phase, where we use fully automated processes, and we we have already established patterns and best practices. We can innovate by using machine learning, and this is where we actually will use all that advanced machine learning practices like feature stores, versioning, CI/CD, continuous training, and so on and so on. So that means don't get mad about all these MLOps hype right now. Applying machine learning or involving machine learning into the business is a process, and we just have to go step by step. Okay, the next point of our here is the hidden costs of machine learning engineering. And every software project will have a hidden costs. Machine learning project will have more hidden costs. And to be aware of all that costs, we use machine learning canvas again. And this is, as I said, I really like this framework because it forces you to think about stuff which is not obvious at the first time. So we will be forced to think about all that infrastructure costs. Can we have this? So if we have increased cloud computing time, so are we capable to pay for it? Or can we afford to include a human in the loop for labeling or for data cleaning? So one interesting point is, if we introduce machine learning, do we have people who will maintain it? So we saw already that post-deployment is as important as pre-deployment. So do we have skilled people to do this? And so on and so on. So this, all that hidden costs, can we like iterate through these hidden costs during the initial step while filling this canvas. Good. The last but not least point. Every time we use machine learning, and if the predictions of machine learning influence decisions which will influence human lives or interact with humans, means we have a responsibility, and we have to be aware of all ethical issues of machine learning, of the application of machine learning during data collection or model training, and right now everyone is stating all that responsible AI principles. What I am missing right now is like a practical aspect of this. So, okay, I want to build a responsible AI, but how can I do this? And recently I discovered this framework, model cards for model reporting, because I'm convinced, and this is similar to the documentation for traditional software. We can achieve a lot of transparency in machine learning if we establish the documentation culture for machine learning development, and this framework, model cards, contains 9 sections, which also like a machine learning canvas guides you through the points which need to be documented, and in this way we make our models transparent and describe describe all details, the use cases, all metrics, and describe the evaluation data and training data. And when you're forced to do this, then you automatically so think about all that principles of responsible AI. The best thing about this model cards framework is there is a model cards toolkit, which you can install along with your project, like a pip install, and this toolkit will streamline and automate the documentation process of your models. It's very practical, so make sure you have a look at this. Well, so here we go. These are 10 principles of machine learning engineering. All of them are important, but some of them are really fundamental, and you probably don't need to worry about machine learning algorithm before you know that you don't have data, so you have to take care about that. Right, so I work at INUQ, and we have at INUQ a lot of stuff. For example, ml-ops.org is a website about the machine learning operations. If you like my sketches, you will probably like this site as well. Recently, many people really excited about the awesome MLOps. So make sure you don't spend much time there, but because there's a huge aggregator of everything about MLOps. But I can ensure that I look at every single link, at every single resource there. So this is a curated stuff. Well, so I think that's it. Thank you very much for your attention. So, and I'm curious about your take.
Yes, thank you very much. So I can definitely relate to everything you said, and especially like in many cases we don't need machine learning, so we shouldn't even bother with many different things. Like if we don't need, we just need to sit and think, is this the right tool? And often it's not. Also, I really liked your like this pyramid, rotated pyramid, when you said like the sort of stages of maturity for MLOps. Yeah, that was like you don't. It's okay. Like I think it was earlier. Yeah, this one. Like it's okay not to have feature stores or some other things. I think I can so totally relate to that. I just want to remind for those who are listening right now, if you want to ask a question, there is a link pinned to the chat conversation on YouTube. So if you click on this, you will go to Slido and you can ask Larysa a question. And we already have a few questions. So the first question maybe we'll start with. The question was, what is the name of the ML document format that you shared? It was, I think, in the point number 10. Yeah, this one.
So just Google for model cards for model reporting. This is a paper. This is a Google paper from Margaret Mitchell and Timnit Gebro. If you know these two names, you will be curious about. You will, if you Google for model cards toolkit, you will get the GitHub repository with all that instructions and examples.
Mm-hmm. Yeah, we will add all this link to the description later.
Sure.
Yes, so then Mark asks, when consulting others regarding such topics, what is the adoption and acceptance rate you generally see? If you can, of course, answer that. Maybe if you cannot disclose that, that is fine as well.
What I can say that if let me, the interesting point is this here. This is where I spent the majority of my time, giving workshops exactly about this. And I can tell you the situation in Germany, and the point is people or companies are aware about these technologies, the AI, machine learning, and so on and so on. But and they probably understand the importance. But what I see, they don't know how to introduce it. And this is why we developed this method, where we go with event storming and try to identify use cases. So what I can say that it was my biggest surprise that many companies are still looking for use cases.
Okay.
So the readiness is there, but they don't know where.
Okay, so they want to use machine learning. They realize that this is important and this will give them strategic advantage, but they don't always know like how to start. And this is what they need help with getting started. And this is where this canvas comes into play, right? So you can use it to actually brainstorm and identify.
Exactly. But first is to identify the opportunity. So and using Canvas to structure, to dig deeper, and to understand every single like here. So every the translation between value proposition and prediction tasks. So you are doing all this here, and right. So and so there is not much methods and practical. Right, practical guides how to do this. Like if we and if you don't have experience, so if you don't create any machine learning models, it's very difficult to find a starting point.
And you also mentioned at some point CRISP ML, right? So it was. Okay, I'm just curious, what is the difference between CRISP ML and CRISP DM? Like CRISP DM is like, I don't know, 20 years old, right? This cross-industry standard process for data mining. Right. And then some people, I think they decide, okay, data mining is old, like probably it needs updating, and they came up with this CRISP ML. What is the major difference between these two?
So basically, right. So the ideas of CRISP ML is quite similar to DM data mining, but the emphasis is on data quality, on model quality, the quality assurance of machine learning models. So they emphasize that there's a lot of testing. Machine learning specific testing which need to be involved into the complete process for deployment, and this is actually the huge or the main difference between these two. But if you know CRISP DM, you will also get well with CRISP ML.
Is it something you often use?
I structure as I see these phases, and I try to go through these phases and structure the projects along these phases. So definitely, so we don't skip the business and data understanding.
this is where Canvas is also helpful.
Exactly. So, and this was so important. And actually, I think this very useful paper in general. So it was the collaboration between TU Berlin and the automotive industry here in Germany. So this is actually one of the paper which actually reflects the real data machine learning life cycle, project life cycle.
Yeah, I didn't know it was coming from the Technical University of Berlin.
Klaus Robert Müller.
Oh, okay, of course. Okay, so we have a couple of more questions. John is asking, if you're joining a team with existing machine learning product, but without MLOps, which practice is best to start with while still delivering value?
So you have machine learning, but you don't have machine learning operational practices. I would think that first I would start with versioning in order, because the versioning will be versioning and testing. So you probably will need to establish these two practices, because the next step will be triggering your CI/CD pipeline to do the all that steps automatically. Yeah, versioning, testing, continuous integration, continuous delivery.
Yeah, and by the way, talking about MLOps, so you mentioned the team, and there was MLOps the engineer, then there was DevOps engineer, and then there was IT Ops. I'm curious, like why do we need three different people, three different operation engineers, or this can be one person?
When okay, the first thing is this picture probably is a little bit idealistic picture, right? So this picture picks not people, but roles. And I think depending on the scale of your organization, you might or you might not need these roles, and you will go well with just with DevOps engineers. And I have to so just because I took this picture from a book, so this is why it's here. So I reference this book. But you're absolutely right. So it depends on the scale of your organization, and so there won't be so many organizations which will be on that big scale.
So we have still one more question. Ismail is asking, in your machine learning deployment decaying slide, how can we be sure about the success and improvements in terms of performance for a new model?
Yeah, so like I told, we monitor machine learning performance, and especially if we are lucky, we can if we have labels, so we can identify the drops. So we will need to establish the monitoring for machine learning specific parts like or metrics like F measure. So we are monitoring the F measure of machine learning model. But as I told, we might not have the access of to labels at the real time. But what we can monitor is the distribution of input values and the output values. So, and if we identify the shift of two distributions, like the train data distribution and the real life data distribution. This might be trigger for alerting that something is going wrong here.
Yes, thank you. So Mitya is already, he already wrote me that he is ready to join the call. So yeah, thank you very much for joining us today and for sharing all this useful and valuable information. And yeah, so, and I really like the style of your slides. So this is very nice, like with this personal touch of drawing everything. Yeah, so thanks a lot.